Hello class. Today we are going to be learning about solubility curves and the units of solubility. Keep in mind, what are some of the factors that affect the solubility of a substance? How much of that substance would dissolve? Well, one of those key factors is temperature. Now, temperature will determine that substance's solubility in a given amount of solvent. And if we plot that solubility versus temperature, what we get is a solubility curve. Now, I've already talked about this, but each point on the curve represents a saturated solution. So if we look at this line here, that represents a saturated solution at that temperature. Anything above the line would be supersaturated, right? More solute than would be dissolved at that temperature normally. And under it would be unsaturated. Now, the solubility of most substances increases as the temperature increases as well. Most substances on here, they have endothermic heats of solution. Therefore, they will increase in solubility as the temp goes up. And that's what you're most familiar with in your day-to-day lives. However, if we look here at cesium sulfate, we notice that its solubility goes down with increasing temperature. What does that tell us about cesium sulfate? What does that tell us? Well, that tells us that cesium sulfate has an exothermic heat of solution, so its solubility actually decreases with increasing temperature. Again, that's kind of the exception to the rule. Most solids will increase in solubility as you increase in temperature. Now, off of these curves here, we can extrapolate data to figure things out. For example, let's say that I gave you a specific temperature, let's say 70 degrees Celsius, and I wanted you to tell me, well, what is the solubility of potassium chloride at 70 degrees Celsius? This just is reading a graph, right? You would trace the temperature up to your line here, and then you would trace it across, and you would get a solubility of about, looks like 47 grams of solute, 2 grams here of H2O. And it's not just grams of H2O, it's per 100 grams of H2O. So if I had a beaker with 100 grams, keep in mind 1 milliliter of water is 1 gram. So 100 grams is 100 mils of water. Now, if I had 100 milliliters of water, how many grams could we dissolve of our potassium chloride? That would be about 47 grams at 70 degrees Celsius. So we can use these curves to make predictions, but we can also use the units of solubility and a little bit of mathematics in order to calculate what solubilities would be at given temperatures, or perhaps we want to know, hey, we know the solubility, and we want to find out, okay, well, I only got 50 mils of water, how much could I dissolve then? So we're going to use some math to figure that out. So what are the units of solubility? Keep in mind, solubility is the max amount of solute you can dissolve in that given amount of solvent. So you're creating a saturated solution. Now, typically, it will be the mass of the solute per 100 grams of solvent. That's usually the means by which we represent these units. Now, keep in mind the density of water is 1 gram per ml, and therefore you can kind of say, well, it's per 100 grams of water, but that's also per 100 milliliters of water. And one more conversion for you, a cubic centimeter, centimeters cubed, that is 1 milliliter as well. So when you see cc's on a syringe, cubic centimeters, this is a really fancy way of saying milliliters. Sometimes you may see it in terms of the grams of solute per liter of solvent. So just be careful when you're looking at those units, because that will impact how we solve our final problems. So, unfortunately, we are not going to be able to do this lab. Normally, we would do a lab, completely described by this procedure here, where we would take some solvent, some solute, add the solute, we would heat it up, and then we would slowly let it cool down until we started to see crystallization. When you started to see recrystallization, what was that point? What point did you just reach? Well, you reached the point in which it was saturated. So if you had a thermometer in there, you could tell me at exactly what temperature you would reach the saturation point. So aka its solubility. So let's say this thermometer read 60 degrees Celsius when you started to see crystals forming. You could say that, that mass of solute in this amount of solvent, its solubility was blah at 60 degrees Celsius. Okay, so now let's do a couple examples to show you how we could work with these units of solubility. First example, if 25 grams of a solute is the maximum amount of solute that can dissolve in 40 grams of solvent at a certain temperature, what is the solubility in grams of solute per 100 grams of solvent? So when we're solving problems like this, the easiest way in my mind to solve them is set them up as equivalencies. Because really what's happening here is we have some ratio of solute to solvent, right? If it's, in this case, we have 25.0 grams of our solute per 40 grams of our solvent. And is that saturation point going to always be the same? Will we always find the same ratio of solute to solvent at that given temperature? And the answer is yes, right? The answer is yes. So because that ratio will always be the same, no matter how much solute or solvent you are using, we could say, okay then, if 25 grams per 40 grams is what we're given, that means that some ratio of our solute over our solvent will be the answer, will be equivalent. So all we have to do here then is solve for x. X represents our amount of solute. So that's going to be 25.0 grams over 40 grams. And we are simply just going to then multiply here both sides by 100 to isolate x. And we find that 62.5 grams of our solute. So we could then say that our solubility is 62.5 grams of solute per 100 grams of solvent. Right? It's going to be 62.5 grams of our solute, whatever that may be, per 100 grams of our solvent. So again, all of these problems, you're just going to be thinking in ratios, right? Because that solubility point does not change. I'm just going to be throwing at you different amounts of solvent, and you're going to have to convert. Let's look at one more example. If 30.1 grams of solute can dissolve in 350 milliliters of water at a given temperature, what is the solubility in, again, grams of solute per 100 grams of solvent? Now we're going to set up and solve this problem the exact same way. So we know that our solubility here, 30.1 grams in 350 milliliters of water, will be equivalent to some amount of solute dissolved in 100 milliliters of water. Because remember, milliliters of water we're talking about here, that's equal to grams. So we know that there's going to be some value of solute per 100 milliliters of water, aka 100 grams of water. So when solving for x, yet again, it's going to be 30.1 over 350. And again, we are just multiplying both sides by 100 in order to cancel out and isolate x. And what we get is 8.6 grams of our solute in this case per 100 grams of water. So that is our solubility. That is a saturated solution of our solute. That is all for today, class. Have a wonderful day.